All right, so today we're going to kind of go through some basic reasons to test. What are some of the code requirements? BlowerDoor quality control, how to test out of order, and ways to ensure accuracy of your gauge and your fan, and common test problems and solutions. So I found that many of these things are very helpful when I get people who are responding about issues they're having or conditions they've actually learned or solved. So in fact, we also have. I thought there was another slide that may not have showed up. So, um, if there is something you want to make sure I'm addressing, do that. I did not do any polls today because sometimes I feel they kind of get in the way. So I'm just going to ask you some questions, and hopefully I get a response in the question and answer area. So, um, for those of you that do have the DM32 Smart Gauge, which will be one of my questions in a minute, is to make sure your firmware is up to date. You basically will plug in your DM32 with a USB cable to your PC, open up the gauge configurator, and it will find your gauge. Just for the record, if it doesn't find your gauge immediately, what I would say is just unplug it and plug it back in. If the first time you've done this and it has a hard time, or you get funky sounds acting as though it cannot find your gauge, you may need to update or make sure you have the right drivers installed. All that can be downloaded from Retrotech website. Right now, they are currently on version 49. So you can see that on your gauge if you go through settings on the last page there, or the last screen. It'll tell you what your firmware is. So you want to make sure you're up to date on your firmware. And this is something you definitely want to check at least once a month in terms of that. So for those of you that may not be aware, that if you've purchased a blower door or duct tester, that we now offer online training and certification. We feel it's very valuable to understand and know how to use the equipment. For an average person, it takes about an hour and a half or so, and it does have some task for you to go do. So you could spend a couple hours on it if you actually went through the entire scenario and setup. So we definitely recommend that. So if you have not, if you purchase your equipment from somebody else or from 2 years ago or something, just reach out to either Jay at retrotech.com. That's JAY. I think it's Jay West. Sorry, Jay West. I'll throw that out there in the response to everybody, or just sales at retrotech.com, and we can actually make sure that we'll confirm your purchase and get you set up with the training. When you're done, you get this nice certification credentials, and basically just says that you understand how to use this one gauge with this one fan. So there's one for duct testers and blower doors. We're finding that this actually is a very valuable certification, not just for training, but in other parts of the state, they actually now acknowledge this as something that you can use to do energy testing, energy code testing. So Louisiana, for the duct tester, you can take our online course and then be certified to do that. So I think in the future it'll be kind of a combination of both. That you're going to need different types of BPI, ResNet, and a manufacturer certification. So this is a great thing to actually put in your toolbox. There is one for the DM2, and that's for the DM2 is the older gauge, and that's actually for the blower door. And there's also one for the duct tester, I believe, also. So I know there's one that is out there for the duct tester. So if you have an older model of gauge, it's also available to you. All the things we talk about are on retrotech.com. I can't stress enough, if you're looking for more information, that's the place to go. At the top under support, you can find the manuals and guides. The manuals are a massive reference for a variety of stuff that you could be looking for, and the guides are actually all the quick guides that actually step you through how to do any of the procedures. So many people open this stuff up, they're like, I don't know how to do this, even though it is very intuitive, and want to call. So before you do that, you definitely want to take your online training and make sure you use the quick guides, and even go on YouTube if you're looking for more information, because a lot of the answers are right there already. So again, the quick guides and manuals are just a phenomenal resource for whatever you're doing. And as this slide goes around, I have a few questions I'm trying to find out. First one is, where are you? We reached back out to our European allies and friends. Somehow they had were not on some of the email lists that were sent out. So what I'm trying to find out is, what state are you in? What country are you in? And that would kind of help me to orientate my session today as to what kind of folks do I have out there. We got a few from Texas and Indiana. Great, excellent. Thanks, everybody. One of the things that's in our quick guides, which kind of gets lost sometimes or forgotten about, is how to check your gauge. This actually is in the quick guide for the blower door and the duct tester and on the back. And today we're talking about, blower door 101. And this is one of the things you definitely want to be doing, if not weekly, if not before a test, or if you test once a month, you want to do it before you do each test. And it basically is just taking your gauge and using the umbilical or the actual tubing you use, and going from channel A input to channel B input or reference, and switching that around. So you're ultimately going to have 4 mini tests that go along with that, and the procedure there guides you through that. And we're going to talk about what's on the other side, which is how to check your fan itself. So we got a variety of stuff from people from all over the U.S. and Canada, England. We have Spain and Barcelona. Thanks everybody for joining us today. That's a huge gathering, and a few from the Netherlands. I've been to a few of those countries and wish to go back. So, if you have anything you want to make sure I'm addressing today, go ahead and throw that out there, and I'll kind of cover that as we go, or know that I need to make sure I mention more about that. One of the things I do want to remind people at is the DM32 will control Minneapolis fans, right? The duct blaster or the blower door version 3 or the 220 or the 110. It also does the true flow grid or the exhaust fan flow meter. All those things are actually able to be accessed on the DM32 smart gauge. For those of you who have the DM2, it would read these devices, but it would not control them. So now there's actually an adapter that can actually be used with the DM32 smart gauge and do that. Retrotech does offer a buyback or a trade-in process. So if you have an older DM2 or if you have a DG700, you can definitely contact sales or even go to that support page I showed you at the website and start a buyback or trade-in program. And I can tell you that it is a smoking deal to take that process or do that or get a new brain or gauge for your existing fan. All the stuff I mentioned before that we've had our webinars that are coming up, and the past ones are all on the YouTube channel. If you're looking for more and more information, a lot of the stuff we've done with our partners are there. A lot of stuff that Retrotech has done in general, it's all there. So if you're really looking to learn more about any of our topics, there's a wealth of information on the Retrotech YouTube channel. Oh, so here's the one slide that I had in here. So these are some of the stuff that I want to make sure we cover today. Why are you testing? Is it required or is it an energy audit? What are some of the code requirements? Some of the stuff was similar. It was a previous slide that I thought I took out of there. So, and how to use the quick guide and some of the problems. So if you're having any kind of issues, I definitely want to throw those out at me so I can cover those as we go. So here I'm going to ask you a few questions. I finally got this slide up ahead of time. So what gauge do you have or gauges? So again, I'm just going to use the question and answer panel. So if you have a DG700, that's great. Let me know if you still have a DM2 or a DM32. And if you have your DM32, I would ask you to kind of check your version of your firmware. It's one of the things you should do to make sure you're up to date. So that gives you an idea of how many people I've got out there using what. So the things we'll cover today mostly cover the DM32, but they're just general practical applications in general. All right, excellent. Got a lot of responses there. Well done, crowd. I'm actually very impressed. So somebody says they do not have a gauge yet, and they're looking for that. So one of the things that Retrotech provides is a lot of great support for how to use your equipment, from the quick guides to the manuals to all these webinars and the online training. So if you are just trying to make a decision about which way to go, the reality is I don't work for Retrotech. I do a lot of work for them, and they're my client. I do marketing and product development, but I think they have a really cool product. I went with them with a proposal about how to help their education, help their product development, and so we have a working relationship. But in general, I do not work for them. In terms of being a hired employee, I thought they really have a variety of great stuff that's changing our industry and changing how we use the tools we do every day. Okay, so if you could let me know what's your market sector. I know this is kind of a, Jay West hates the word industry, but it's kind of like, what's your industry? Are you a HERS rater, BPI, weatherization, code official, just energy auditor? oversee programs, HVAC contractor, anything that fits any of your descriptions on how may describe yourself when you're at church or a social gathering. That would help me a lot. It's let me know where you're at or what you're doing. And how do you describe yourself in your job title? They may be one and the same, but my goal is to kind of get a feel for what kind of folks do we have out there and what you're doing. So many things we'll be talking about are very similar to BPI protocols and HERS applications. So some people may be more administrative that are on our call today. Some may be actually in the field. So my goal is to make sure you understand a variety of stuff. So I'm going to start first with the QA part of this, and that is that how to do a field check on your fan. How do you know that your fan is working correctly? All right. So it's easy to check your gauge because you can actually take tubing from one side and put it in the other side and go back and forth. But your fan is a little more challenging, and your gauge could be off by 1 or 2% in theory, and it will not affect your results drastically. If your fan is off, that will actually skew your results much more extremely than actually your gauge could. Because even when you extrapolate 1 Pascal in terms of the CFM, it's not a large result. But if your fan is off by 10%, now you actually have a large discrepancy as to what your results might be. So here's the scenario. You can follow in the quick guide on how to do that. These quick guides can be downloaded from retrotech.com on the same page under manuals and quick guides. So what I'm going to do is set up my BlowerDoor in a small area. You can use a bathroom, you can use a closet, it works best, a very small bedroom. The smaller the room, the easier it is to actually do this type of a test. What we want to do is do a test and test the leakage of this room to try and find out what it is and use that as a baseline or a neutral number. And then I can actually use that in terms of subtracting how much leakage it has. So what I'm going to do is set up my little room. If you're going to use that bathroom, you got to make sure you cover the register and the fan, because those are actually leakage points that you really don't want to have. So if there's any kind of opening that's a known opening in this little room, it should be covered in general. All right, so here's my process. I'm going to take the room. What I did was actually cut a piece of plywood. You can use a piece of rigid cardboard. You can use a variety of things that are firm enough to handle the wind in the test itself. I went to the gauge, and under your results to be displayed, you can access this by just tapping channel B, or under settings at the bottom, you can do results to be displayed. And then you tap the little dots on the second screen is the EQLA in square inches. On the first page at the bottom, it's got EQLA. I think it's at 10 Pascals. So on the second screen is multiple EFLA, EQLA, but the top one is just actual pressure in square inches. You can actually change that to cubic meters or feet per square feet. So there's a variety of options by just retapping on this exact same area, and I'll be changing the results in that itself. So here is set for EQLA square inches. So when I run my test, I'm actually going to determine what are the square inches of leakage. All right, so I know that the opening that I have is a 12 by 12, so that's 144 square inches. So you can test at 25 or 50, making sure that everything is secure if you're going to go to 50 Pascals. All right, so the results of my first test with the opening that I have in my cutout were give me an equivalent leakage of 168 square inches. All right, and so that actually is what I measured. All right, and then I'm going to cover the opening and do the same test again. And now the only thing I'm going to have is the background leakage. Right, and so my results were 24 square inches of leakage that's just naturally in the room. So I'm going to do is take my 168 square inches, subtract it from 124, and I get 144 square inches. So this scenario, I was dead on just to show you what the numbers could look like. So again, you're going to test it once, and you can do the same pressure for each test, but test it once with the opening so that actually air is coming right back at you once it fills up the room. I'm blowing into the room, it's the little room itself, and then I can cover that back up. And my goal is to try and find out the difference between the two. So this is a great way to also just practice or play with your blower door. Sometimes you can actually, on cold days or other days where you don't want to mess with your conditioned air on your house, you can actually just use this same method. You could use it in a bedroom or something, and just don't put the frame all the way to the top. Allow a large amount of air to move throughout the room and into the room, and you can actually play with the blower door numbers, and actually get a live practice scenario going without actually having to put it in your front door. So you can use a bedroom or a closet or something similar, as long as you actually have air that can move across the top of the frame. So some of the reasons that people test are to do energy audits, find conditions, improve the performance of the house, or a variety of code. And I appreciate all of the European folks that are out there. I'm not as savvy or up to date on some of the testing protocols that you guys are required to do. In general, it's a blower door with a number and a criteria. But some of the stuff I'll talk about are mostly the American energy code, and I am been instructed to kind of get more up to date with your codes. And starting next month, we will have these same webinars that are designed for your specific standards and using your same types of units of measure. So to me, there's two ways of actually doing the test. Let me go back to this slide previously. So if I'm going to do a code test or a ResNet test or something that has a specific standard, the European equivalents, France has theirs. There's a lot of them that are out there, and they have a protocol to follow. Or I actually am just doing a test to see what's the performance of the house. Usually that's an existing home. I have two options. I don't really have a slide that does that, but it's a discussion in general that if I'm going to go to a house that's an older home, it may have suspect conditions or a variety of stuff. And I can pressurize or I can depressurize. And those are your choices on how you actually want to decide what type of test you want to do. So if you decide to pressurize, any type of exhaust fan or other types of ventilation has a damper on the outside to prevent air from coming back in when it's not in use. And that will now be blown open. So your leakage would be higher under pressurization versus depressurization. But if I was just trying to go to a house and I didn't really want to do a depressurization, I didn't want to bring in conditions based upon this home or homeowner, it's okay to pressurize and actually know that I'm blowing things away. And your goal is to just make the home tighter. So as long as when I come back after I've sealed the house and do my test out, as long as the number is less, those other openings are always a consistent. So they're always were there. So if you are doing the US 2012 IECC Energy Conservation Code, then these are the requirements for you. And I'll talk about what air changes per hour is briefly. But it basically is, when I'm doing the blower door, how many times is the entire air in the house pulled out of the house, basically. So how many times does the air completely change in the house while the blower door is going on? So it is air changes per hour at 50 pascals. And in climates 1 and 2, which are very minimal, like climate 1 is just the tip of Florida. Climate 2 is just chunks of Florida and kind of runs across the coast in the bottom part of America. The majority of everybody in the U.S. is in climate zone 3 through 8. And most are actually in 3 through 5 in general. That's the larger chunks of folks out there. 3 air changes per hour is a fairly tight home. I know in Europe, some other standards are actually getting to passive house, which is 0.65 technically to pass. So there is some room for us to even get better. And whether the house is too tight is a debate I gladly accept and take on for folks. So who gets to do the test is dependent upon your municipality or what your code official is, or who's allowed to do that. Is very vague and has its own criteria in general. So most people accept, obviously, an energy code official to do the test. Some allow BPI, HERS raters, or other similar certifications. Some are beginning to allow the manufacturer certification. What you need to do for a blower door test for the energy code is incredibly minimal. It basically just says that our windows or dampers or interior doors just basically opened or closed, but nothing can be sealed. If there's a dryer that's missing from the laundry area, you're not allowed to cover that opening. There's a damper on the other side that should be now in effect. So it's basically as is what your goal is. Seal the house up on the exterior shell, open the interior up, and now you're actually ready to go. You do not seal the registers to make sure we're on that same page. So for the ICC, there's some very large items that are missing, and I think that they've realized this and are working on a better testing method. So there's nothing about combustion safety. They kind of feel as though it's a new house and those things shouldn't really exist, even though gas is probably on. The furnace and hot water tank have already been prepped and ready to go. This is ready for occupancy, and you're coming into your test. So you do want to make sure a variety of things are either off or not able to come on. It doesn't cover issues about baseline or windy days. What's the technical way to measure the structure? What are the equipment requirements, the certifications? A variety of stuff has kind of been left out. So I think in the next scenario, which is going to be 18, these things will begin to be resolved. Just for a general comparison of the top here, which has the energy conservation code in general for residential is about 11 to 12 pages. It's not a large, exhaustive document, but the part that covers testing is only about a quarter of a page. And if you compare that to the ResNet standard of Chapter 8, it's about 27 pages that covers all of the details on how to do a blower door test. So I think you're going to find that these two things are going to be slowly merging, and the code will start to adopt many of these conditions that ResNet has or many other testing standards have. I'll do some things briefly about the air barrier and some other stuff. So in the code, there are these definitions about, air barrier. So 2009 introduced that. The black lines on the sides of most code documents mean that it's either new or it's changed. In 2012, they added redefined air barrier and then added continuous air barrier. So these are things that are in the code itself. One of the things we want to talk about are some of the challenges or making sure that you're passing this test, no matter who or where you're doing it. So the code, the IECC has this 17 items that you should be air sealing and checking and doing. So if you're working with a new contractor, somebody in new construction, this checklist is an enormous leap in terms of trying to make sure things will pass later. Because once you go just before occupancy and you do a blower door and it fails, you are struggling to figure out and find out where do I go to find all these leaks. I'll give you a couple of ways to do some checking at the end, but at that point you really are cutting open drywall or trying to find some large issues. But if you went through this checklist and actually worked with the builder or they did themselves to make sure these areas were sealed, it's a high degree of success when these things are actually addressed. Some of them are some very large holes. If you, and I will shoot out the actual link here in just a second, South Face here in Atlanta, Georgia, has these phenomenal illustrations that talk about all of these air sealing locations. And all the numbers actually coincide to the numbers that are in the code book itself. All right, so if you can see all of these great little areas where things should be sealing from behind the tub, below the tub, around a variety of other openings, all actually add up to high degree of passing. So you can see some of these that have changed from air sealing and adding additional layers. So in the attic, it used to just be exposed insulation on the knee walls. And now they actually have tried to go to putting up an air barrier that's now sealed on the attic side. So it's a lot easier to add the insulation from the interior. I'm going to shoot out right now to everyone. If I can, these links that I've got up here are actually the links to all of the illustrations that you just saw, and there's a lot more, and a book on how to actually do the work and how to seal these. And what I'll do is I'm just going to pick one type here. All right, so I just I responded to one question and sent it out to everybody. Is the only way I could see how to do that quickly. So I just sent you those two links in your chat window that you can see them. And now you can actually go directly to Southface and download those. And if you did write them down, they are case sensitive. So they are a phenomenal source for individuals, builders, anybody who really wants to make sure they're ahead of the curve. So the reason that we're doing an energy audit or a blower door is because we take these nice homes and they probably would be fine if we didn't have any windows and doors. They would probably be fairly well sealed. I'm sure they would still have a few issues or connections internally, but so we cut all these holes in them and then expect them to still be fairly tight or not actually have a lot of issues with the leakage. But the reality is, I kind of feel that most of our houses are more of a Swiss cheese kind of a concept, and it isn't just from the shell or the outer perimeter. It's also conditions that actually exist on the inside. So we actually have a variety of issues that go from floor to floor, or from floor to attic, or floor to crawl space. So these are many of the penetrations that actually cause problems that we can find or isolate when we do a blower door. So many of these are going up to the second floor or to the attic. And it isn't always just the perimeter that's our leakage issue. So when it's said and done, we end up really with a house that has various holes and conditions that we must figure out a way to seal or get back up. So the pink is actually our thermal barrier that I have on the slide, and we have an air barrier, which most air barriers are drywall. They can be a variety of materials or assemblies. Right? They can be on the inside, they can be on the outside. They should always touch the insulation. That's a crucial element for making sure your thermal barrier works, is when the air barrier is touching it. So here, if I just had a one room structure and my air barrier, no windows, no doors, I probably could do a pretty good job of sealing it. I bet this would be a very, very tight structure. But instead, we decide that we're going to add a bunch of rooms and partitions. And so now you can see how the air barrier has been chopped up. But notice that the air barrier did not actually go or stay with the thermal boundary at the top or the bottom. And of course, then the next contractor comes in and he wants to cut a bunch of holes and add some wires, some ducts, and a variety of other stuff. So these are the things that actually make our homes the Swiss cheese factory that they are. So now I can have connections from a crawl space, or at least down to the interior, up to the attic. We add a duct system or can lights or junction boxes. Again, all these things are all cutting holes and openings into our air barrier. And these are all the kind of things that we're trying to measure. So if it's new and I'm trying to pass a certain code criteria or existing, what we really realize is that what we have now is actually the air barrier. If you follow it around, it then is part of the junction box, or as part of the duct system is now your air barrier, or the can light. All these things that actually penetrate your air barrier down below then become the air barrier above. So not a lot of people realize that your duct system, if you have any kind of air handler or metal duct system in the attic or crawl space, when it penetrates, it then becomes the air barrier itself. So in general, we set up the blower door, and it's in the front of the house. It could be in any door that will work as long as it has a clear path on both sides. That means there's not a lot of restrictions in the front, or not a lot of restrictions in the on the back side. So if you have a home that has a real tight hallway right behind the door, it can also be very restrictive in terms of your test. So I want to make sure that I have lots of airflow on both sides. You can use a garage door as long as the main overhead garage door is open, or a back door and the door is secured. So you can see where, when the blower door and I'm depressurizing the house, so I'm actually pulling air out of the house through the fan, and it will measure the pressure. And what happens is that pressure then is converted to a CFM number. So it doesn't actually measure CFM, it actually measures pressure inside the fan. And then that pressure is converted through the calculation similar to what we did earlier with the hole above the blower door when we were doing a kind of a calibration check. It actually converts that pressure into a known opening size, or into a CFM. So this is, in general, the visual on how the duct system becomes part of the interior and the air barrier itself. That may the same one. So we talked about air changes per hour. So while the blower door is actually going, it is able to calculate when it knows the volume. You have to actually put the volume into the gauge because the gauge will give you this information automatically. So the gauge gives you your code results for duct testing and blower doors. So you can actually go to your results to be displayed and you can pick air changes per hour. You have to enter a volume. So you must know the volume of the house, that's the conditioned area. And so then I can actually run my test and it'll actually calculate the air changes per hour live as I'm doing the test. All the things that RetroTech has always offered, I felt that this was one of the most valuable things in their gauges. The DM2 has it, and the DM32 does it, and it's a phenomenal resource in terms of people who do code testing. So once I have this number, now I can determine if I'm actually compliant with the standard that I'm after. Some other standards are actually leakage per square foot of the surface area and a variety of other conditions, some of which are in the gauge, some of which are always being added to. So that's why it's always good to keep up with your firmware. I put this in. This comes from buildingscience.com, and it's in many of their books that they have on the builder's guide. And you can go online and find this. It's a phenomenal slide that shows. In fact, I usually hide some of the stuff, but if you can see on the left, these are just a 4x8 sheet of drywall. They both have talk about how much moisture can move through. One of them, they added a 1-inch hole in the middle. And so on the one on the left just has diffusion, which means that the water moves through the drywall. Over 1 week, 1.5 pints of water will just diffuse through the drywall. On the right, 14 pints of water will not just diffuse through the drywall, but also go through the 1-inch small hole that is in the drywall that they did as their test method. So an average home, even if it's fairly tight, still has around 2 square feet of openings if you gathered them all up and put them into one. Older homes can have anywhere from 3 to 4 square feet. That's right, 3 to 4 square feet of opening. So you can imagine the amount of moisture that also moves through these homes, and that's a major load for your HVAC system, comfort issues. One of the reasons why I always preach that the blower door is a major tool for HVAC contractors. So in general, how it works, sort of the theory is, so I have my blower door I set up in the area. Right now we're going to be inside the home, so it's pulling air out of the home, as you've seen in other illustrations, and there is a small opening or orifice in either the rings here. I have C, or I can change the ring, so it knows how large the opening is. It knows what kind of pressures are moving through it, and then it can actually calculate the CFMs that's in there. What this allows us to do is to compare home A to home B, or retest a home and come back to it again. And it's just a great method of standard measurement. So it's nothing's perfect, but it's a great tool in terms of trying to evaluate the leakage. Is it 100% accurate? I don't think many things are, but it's one of the best tools we have to evaluate envelope leakage or a variety of other diagnostics in the house itself. And again, I have another visual on how we try and do a pressure difference from inside to out. And I use this as an example of how we're going to use diagnostic tools later. So the blower door is now pulling air out of the house, right? And I have a 50 Pascal difference from inside to outside. That means all of the openings, in theory, are bringing in 50 pascals. It's more of a concept than it is actually exactly how you do it. So the point is, I can now go around later and I can actually try and find issues, which we'll come back to in just a few minutes. But this is the kind of concept that we're trying to see. Is if I have this test operating and active, then I can actually go around and check different parts of the house to try and find out what is outside or what is connected. All right, so for the test itself, you definitely want to check your building before you perform a test. All right. So I will ask a question here. And to be honest, I do not go back to anybody, but I just try and see who's willing to admit. Before you operate your blower door, All right. Do you do these few things? Do you fully evaluate or at least poke your head in the crawl space or the attic? Do you acknowledge what kind of condition the duct system might be in? Are you, of course, locking the doors and the windows? Do you check the garage? The reason is that there could be various conditions, especially in the crawl space or the attic, that would not want you to do a depressurization test. So sometimes you go in the crawl space, it's full of standing water or variety of funky things growing on the sides, and most of these kind of structures are fairly leaky. So are you actually acknowledging the condition before it? And the one that I usually ask people is, are you asking the homeowners, do they or does anybody in the house have any kind of asthma triggers or breathing issues or asthma in general? Because if you don't ask those questions, I personally feel you could actually create scenarios in the home or the test that may not actually be apparent exactly then, but could be a couple of days later. So I highly encourage you to make sure you're asking those kind of questions to the homeowners before you do the test, and do a quick visual. So we do want to make sure the building is prepared. I know that all of my outside windows are and doors are closed and locked, interior doors, and I say it doesn't have to have a vent or anything. I think that the entire house should be opened up on the interior, because you never know where there may be a connection that you'll be able to find or feel air that moves through. Here's a laundry list of stuff to do for existing homes or mostly after combustion issues or things. So hot water tank, we're going to turn it to pilot. And as you can see in the arrow there, we want to make sure we leave our keys there. So later I don't get calls saying there's no hot water. The fireplace is your next largest risk, and you want to make sure there's no hot embers, first of all, or if there are any kind of ashes, you either clean them up or put wet paper towels or wet newspaper on top of them so they do not get blown in. Anything else that's moving air needs to be turned off or not able to be active. So your furnace or your AC or anything that can move air needs to be turned to a temperature so it won't come on or turned off. Dryers, exhaust fans, all that stuff is off. If it's a new home or hasn't been occupied in a while, you want to make sure there's some air in the traps. That means in the toilets. I mean, the toilet would be pretty dry if it needed that, but it can happen for homes that are been occupied for a long time or vacant. Also, the tub or the sinks, their traps can be dried, and if you start doing a blower door, suddenly you're going to have some very nasty smells come into the house, and you of course blame it on your partner you're working with at the time. But the reality is, if you smell anything that smells like sewer, it is, and you need to go around to make sure you add water to all the traps to control your leakage, but also get rid of the smell. So again, safety first, all right, and do no harm should be your main criteria that you're doing when you're doing the test. I would encourage you to accept that this house could not be tested in the condition it's in, repair those things, and then come back. I think that would be your greatest asset that you could ever do for a homeowner. So you've installed the door frame. If you've not seen the new frame that Retrotech has, all the corners are very tight. They have some phenomenal, very nice rigid weather stripping that goes on the outside. If you do have this, you can actually take the entire frame and collapse it down, and what I would say is kind of rack it, just kind of tilt it to the right or the left, and the entire thing comes apart. It's a great new frame that they have. It comes with two crossbars, or you can use your thumb to pop it apart. So the system is installed. I made sure that my tubing, which is on the right side, does not look like that. All right. All of my connections are all color coded. They're fail resistance. You can follow the quick guide step by step to go through this. So make sure you have the correct device. That's the number one. So I'm going to tap on the image itself to select that. And if any of you have seen the new update that the Smart Gauge has, under blower doors, it actually has duct testers under the blower door option. So if you go to devices and you go change device, and under blower doors, you'll see the duct tester image. And that's because you can use the duct tester to do a blower door test. A lot of passive house does that. So you want to make sure you have a blower door and the right one selected. Yeah, they now are putting stickers or identifying labels on them to keep track of which one you have. A lot of people, once you have it, you do it. But if you have several employees, you're like, well, I don't know which one it is. So, if you do have that scenario, I encourage you to get a marker out and put down which one it is, so your employees can keep track of it. Somebody did have a question out there, and they said, "What is the AHU?" And that's the air handler unit, or the large blower for the furnace or the air conditioner. So that's, I had that on a previous slide. So if the when you first tap on this, the first thing that pops up are all the different ranges or rings that I actually will use for the test, and then at the bottom I can also do a change device. So once I have the right device installed, then under channel B I can select the units and the results that I want. So I can have CFM, I can have air changes per hour, I can have EQLA with a variety of other options. So you can tap here or under settings at the bottom there will get me to that same screen of changing my results. So under settings, I have a variety of options. So there's my volume. If I'm going to do air changes per hour, to change that, baseline is there at the top. So baseline is very straightforward. I actually will select baseline, and it will say capture. And I encourage you to watch your results as they're live. If you have a really windy day, if you're really struggling to, get readings that are stable, then you would want to do a baseline that may be a minute or even 2 minutes. Those are the kind of things that are going to give you a good solid baseline to allow your measurements to be much more accurate. If you realize that it's not a windy day, there's hardly any impact upon your readings, then you could easily do something that's as short as 10 seconds or 30 seconds, because there's not much of a change. And the time average is also on the first screen in the settings. And at the bottom, you can also see results to be displayed. That's the same option as we had previous. Air changes per hour is based upon volume. So the larger the house, the easier it is for them to pass. So if you have a small house and it's trying to get 3 air changes per hour and it's on a slab, those are actually some challenging numbers to get. I've learned that many of the builders that are out there are doing it. There's a small learning curve, but they're just pay attention to the details and they're able to conquer that. So if you add more volume, it's a lot easier to pass, is really the bottom line. So you're mostly after the conditioned area. That has multiple definitions throughout your testing method or your criteria. So to calculate the air changes per hour for the International Conservation Code, the ICC, so I'm basically going to do the final fan flow, which is the CFM 50 that I get from the gauge. You multiply that by 60 and you divide it by the volume. So here I've got 1900 CFM times 60 divided by 33,000, and it equals 3.45 air changes at 50. Or I can enter the volume and get the gauge to do this automatically. So this is why I think the gauge is really very intuitive and considered a smart gauge, because of the things it can help you do with your testing method. This is my son setting up a test. This takes maybe about a minute and a half or 2 minutes, but I thought I would just show you the whole process. So this is the new case that they have for their fan. Those are the quick guides that come with the frame itself. So the frame has a new cloth cover. You want to snap the corners together. They're all numbered and labeled. They're going to loosen the knob. So I now have the basic frame. Everybody has their own scenario or method for doing that. But notice that I leave a small gap of about a finger. There's the 2 crossbars that go with it. And one's really designed for the bottom and the top. Everything again has a number system on it. And now I actually have my frame. I can roll out the cloth and lay that down on top of it. You do not need to stand on the cloth if you do not want to. I want to make sure that was apparent. So I'm now going to just tack it into place so it can be put back up. And now I'm actually going to secure it, putting my foot in the bottom and pushing up onto the top and across. So you notice where his thumb is as he goes across there. I felt if I made this real time, we would be here for a long time, but I thought I could actually just go through a quick setup to make sure that you can understand how simple it is to set it up and go through any questions you might have about it. I have a few more changes I want to make on this, and then we'll have this up on YouTube. Notice that the reference tube that goes outside is well out of the way of the fan. because I want to make sure that the fan is not blowing any air on it, or it's fully away from even vibrations that come with the fan itself. So the quick guide helps you set up the gauge. I usually put it in my hand to make the connections. There's a nice new clip that allows you to hold it on the upper crossbar. Power's on. We set it up. Again, our quick guide is what actually allows us to do this. We've actually handed the quick guide to people that have never really done a test or aren't in the industry, and within about a half an hour, they can actually set up the test, run the baseline, get the numbers, set up the range, and get results just by following the quick guide from step A to step B. You can actually run this test by using the speed control knob on the fan, or you can actually use the gauge itself to do that. So I know that went by quick, but my goal was to kind of give you an overview about how simple it goes up. If my son could do it, I guess would be the question. That it is able to be done by many. Your fan and gauge both have calibration certificates. If you've lost those, you can access those. Send an email to the technical support, call them up. They can be sent to you, and soon you'll be able to go access them online or share those with people. So the goal is that you would actually know that things are in compliance or could share that. In general, if you check your fan even once a month, even every 6 months, to be honest, you probably confirm that it's right. It is considered to be accurate. Checking your gauge every week, worst case every month, you'll know that it's usually, if it's off, it's way off. It's not like, oh, I'm slightly off by a Pascal or two. You're really kind of far off. So most things do not need to be sent back for calibration unless your training or your testing method requires that you actually prove that. So if it does, then there are reasons that you need to actually send it back. So some of the most common problems or solutions is that the reference tube that people have out front is on the windward side, which means a lot of wind is blowing into it, or it's in front of the fan and the fan makes the tube vibrate. If the tube vibrates, it actually will adjust or fluctuate your measurements. You can take any manometer you own and connect a piece of tubing to it and just kind of like shake it, and you'll actually watch the numbers vibrate or change, and you can see that actually could be the same condition with the fan blowing on it or in front of it. Somebody asked in Europe who can calibrate. I don't know the answer to that. The only thing I do know is that only the manufacturer can do that. I don't know if you need to send that back to Regtech or if they actually have somebody over there that can do that. So I would say if you could send an email, Timo, to follow up on that, that would be the answer. I don't know that, but that's something I will make sure I know for the next time I offer this webinar. So this is one of the most common ones. So let's say that this is the only door that actually is practical that you can use. None of the other doors allow the blower door. So I have to kind of put it on a windward side. It may be challenging my results, but I don't have to have the tubing, the reference tubing, on that same side of the house. That tubing can go all the way around either way you want it to go, even to the back of the house. You would really prefer to have that tubing not in the wind. So there's a different method you can use, or you can just extend the tubing so that it would go all the way around to say the wayward side of the testing home of that day. I do have a few slides about how to use a pressure pan when you're doing the blower door. The pressure pan is actually just a large, I need to get a picture on there to show what it looks like. It's just a large piece of plastic, kind of looks like a cake cover. In fact, you can make your own with some weather stripping around the edge and the ability to plug a tubing into it. So that what happens is I can get the blower door up and running. So I have a pressure difference of 50 pascals. And I got my pressure pan, which you can see an image of it here. It's probably about maybe 14 inches square, and it's on some kind of small pole. And I can put that over the ducts or any opening in general. You can put this over the exhaust fan. Again, nothing is on right now. This is the same time that I do my standard blower door test. So what I encourage people to do is do your blower door test. And while your test is running, I get my numbers. I can find out my air changes per hour or my EFLA or whatever I needed for my requirements. And then you pick up your pressure pan. If you have a second gauge, it's very easy. Otherwise, you can use the speed control on the fan to get your fan going to 50 and walk around with the gauge itself to 50 pascals. So while I'm having my fans can be at 50 pascals throughout the house, anywhere where I have these openings, I'm looking for large numbers to confirm that I have leakage or connections. So I have these orange areas which are showing some leakage. So here I actually have a fairly small number. It's 0.9 Pascal. Anything less than 2 is considered acceptable. Here I have 6.8. There's definitely a large leak that's in this duct system that I have right here. And I go to the last one, and I got 1.1, which is still acceptable. So I now know that I have a large leak in the ducts in this area. So it's not over here, not over there. So I know that it must be in this area. And it doesn't really travel all the way across the ducts themselves. It really is isolated as to where the leaks are in relationship to the opening that you're putting the pressure pan on. This does not measure duct leakage as a quantifiable number. I cannot get a CFM number out of this, but I can get a quality. I can determine where my issues are or where my leakage is. This can also be used in various places. If I have maybe I have 2 bedrooms that are side by side and I find out they both have a high leakage number. So this is 7.2 and the one next to it is 7.2 also. I actually now know that when these numbers are the same in the attic, there must be a place where they come together. And that's where my leakage is. So it's not actually in this individual runs because the numbers are so identical. So one of the things you can do is instead of doing my ducts, I can also, again, my blower door is also running. And now I can test other openings. It's hard to do a ceiling fan because the fan's kind of in the way. You can use small little pressure probes to get inside areas to find out what they're at. You can also do zonal pressure, which I can now check and see how connected is the garage or how connected is the attic to the interior, because anything that would measure 50, all right, again, we go back to that slide I had a little while ago. So if I had a negative 50 going out here, that means anything that's 50 coming in is considered outside. And I'm actually referencing the house itself. So you can see that my blue tube is going to the input and the red reference is just the house itself. So when I put my pressure pan over this can light, it measures 50.2 pascals, which means it is directly connected to outside, has a lot of leakage on it. I can actually move that all the way around and even go over to receptacles or switches or any kind of opening. And the closer I am to 50, the more I am to outside. All right. So if I have a receptacle or switches or other things, you actually can feel the air. But if I really want to like quantify what kind of numbers I'm getting and what kind of connections I have, that could be connected to the attic or the crawl space, or maybe there's a light fixture on the back side of that wall. You can also do it on interior walls to find out what kind of connections they have on the attic or on top of the into the attic. So here's one of the questions we had: is this okay to run my reference tube straight out? Obviously, it is not. This slide should have been further earlier ahead. I was wondering what happened to it. So not only will air blow directly into it and affect your readings, but it will also vibrate your hose, as I mentioned before. So this is definitely a no-no. So you want to make sure it goes far off to either side and does not sit in front of the fan also. That wraps up our hour. I'm going to see what I got next. What I do have is a few slides on software. I'll go through those kind of quickly and answer any questions you might have. So one of the things that we'll talk about is if you have a Wi-Fi gauge, if your gauge is a DM32 and has Wi-Fi options, and there's various software things you can do. One of which I can use a PC to control the fan from anywhere in the house. The gauge itself creates a Wi-Fi signal. Your laptop creates a Wi-Fi signal. Or I can actually have a router create a Wi-Fi signal. So there's different options on how I could make this connection between the network. So once I'm doing the connection and I am on my PC, if I have internet, then I can have options of sharing my screen with anybody else that also has internet, no matter where they're at. So if I'm having problems or want to share my results that I'm using to test my gauge, when I'm using a PC, then I can actually share my results with anybody across the world. So this is becoming a quality assurance and quality control procedure that some people are trying to follow or learn to do. But again, it requires that this whoever's doing the test has an internet access, and the other people know how to do the screen sharing themselves. So it has a little bit of technical challenges, but it is something that is very interesting. You can also give control over to somebody else, and they can actually also control your gauge from across the world. Is the reality there? So there are other uh, different options. So you can use Gauge Remote, which works on Apple or Android devices. Virtual Gauge is what I just showed a second ago, and it works on a PC. So you can download from Android or Apple. Gauge Remote is all one word. Sometimes searching RetroTech is easier access to it. And this is actually doesn't show up on the phone search, but it does show up on your iPad search. So if you, at the very top left, it usually wants to know, if you're on the Apple side, it wants to know, are you doing iPad or a phone device, iPhone device? And this is actually a tablet device. So an iPad device. Here's what's coming up down the line. I'll give a quick overview. I changed size of the slides and they got tweaked. But we do have an app out that will be out in about 2 months or so. It's called rCloud. It'll work with Android and Apple. Also works on your phone, tablets, anything that's a standard tablet. And also work on a Microsoft Windows. But your goal is to try and have something that has a 4G connection. You can select what kind of tests you want to do, BlowerDoor or duct tests, what type of testing method. And we are working on getting all of the UK European standards to also be listed here and what kind of tests you want to do. You can geolocate, time, date, stamp, exactly where you're standing when you do the test. It does your test fully automatically. Asks you if you want to save your results and puts them up on the cloud and puts them up on a map that you can share all your results. This will change how a lot of people across the world will be doing testing because it's fully automated. Actually secures exactly where you were standing when you did the test and allows you to share the data and keep track of your data. So for ResNet people with providers, this is a great value. For people that are doing code, you can share the results with your code officials before you leave the house. So on the report itself, it will actually have a link to the map and has a link to your calibration certificates that are on there. So this is actually we feel going to change, again, how people really go through and what type of options they have to make sure they validate their data. That is wraps up my basic overview. Bearing no other questions, I will go ahead and wrap it up today.